here here we have next question, that is evaluate the value of limit x tending to pi by 2 fx, where fx is fx is a function as shown in figure. So let's say first function we have for this. So let's say this is the function 0 to pi, and this is pi by 2 and 1. Second function is like this, 0 pi by 2, and this is 1. Now let's say we have third function like this, pi by 2 pi 1. Fourth function we have here like this, pi by 2 1 and pi. So we have different kind of function at this place. You can observe that limit x tending to pi by 2 fx is equal to 1. In all these cases, you can observe these all are tending to 1. The limit is tending to 1. So this is very simple to get the limit. But these four, if we combine these four, this will deliver a very good concept of limit. And what that concept is, you can have that concept here. That is like pi by 2, this is 1 here like this, third and fourth like this. We have these four functions pi. So if, as you can see, if we approaches pi by 2, the function approaches 1. It's pi by 2, this approaches toward 1. So here you can see this is approaching toward 1 as we approaches pi by 2. So from here we get a very good concept, and what that good concept is, as we approaches pi by 2, function is approaching 1, and the limit of function is not depending on the path traversed by function. It can traverse any path, but limit of this function actually depend on the number toward which it is tending. So this concept is very important. This can be good for a limit calculation, like a limit like x tending to 2y 3x plus y upon x minus 2y, like this kind of situation, or 3x minus 2y, this type of situation. You can assume y equal to mx to calculate this kind of situation. You can assume even any function, so that this can be calculated easily. So let us move on. Next question to get the different kind of situation. Let us have next question here. Evaluate limit x tending to 1 fractional part of x. This is the fractional part function. We can have fractional part of x is x minus its integral part. That's this. So to calculate this, what we need to calculate? Right limit and left limit. So right hand limit is equal to limit x tending to 1 plus, and this is x minus bracket x 1 minus x. Even limit we can apply limit h tending to 0, assuming h is a very small positive quantity. So this can be written as 1 plus h. You can see this h factor, h is very positive, we are taking h as a positive number, minus this is 1 plus h. So limit h tending to 0, this is gonna be 1 plus h, and 1 plus h greatest integer is 1, so this is minus 1. Hence limit h tending to 0, this is h, and you can get this is tending to 0. Right hand limit is 0. Now let us move on the left hand limit. It is limit x tending to 1 minus x minus bracket x. Again we are having h as a 0, so let us apply limit h tending to 0. H is positive quantity, so we will replace x by 1 minus h minus 1 minus h. You can see why we are replacing x by 1 minus h, since this number is very less than 1. So whatever number this is less than, this h is fulfilling their criteria, assuming h to be positive. Here limit h tending to 0, what we can have? This we can have 1 minus h, and this is less than 1, so its greatest integer is 0, and this is 0, this is equal to 1. You can get you can see the right hand limit, that is limit x tending to 1 minus, even the left hand limit of fractional part of x is equal to 1, and right hand limit is 0, that is limit x tending to 1 plus fractional part of x is equal to 0. You can observe this, the right hand limit is 0, left hand limit is 1, so this will not the limit does not exist. So limit of this function does not exist. You may be surprised this that fractional part limit is getting 1. Even you can see fractional part of x is always belongs to 0 to 1, and it can never be 1, but here what we are getting? 1. So again what we say, this what we are telling, we are not saying that this function has value 1. We are saying the fractional part of x is tending toward 1, and not the value of x at 1 is 1. So there is difference. We are telling this is tending to 1 and not exactly the value of this is 1. So this is the correct. Hence limit of this is does not exist. Let us move on next question, that next basic question, that let fx equals cos x if x greater than equal to 0 and 2x plus k if x less than 0. Find the value of constant k so that limit x tending to 0 fx is equal to exist. Here this is the question, you can get it. We need to find the value of constant k. At the moment it is given that the value of this limit exists. It implies its right hand limit and left hand limit both are same. So let us have right hand limit at x equal to 0. So what it is, how much it is, limit x tending to 0 plus fx. Fx is for 0 plus, you can see x is more than 0, so this function is cos x, and you can see limit x tending to 0 plus, here what will be, this is tending to 0 plus, so you can have cos x, the same function we have. So if it is 0 plus, then this will move toward 1, so this is equal to 1. And left hand limit at x equal to 0, limit x tending to 0 minus fx. So fx would be replaced, since x is less than 0, so fx will be replaced by 2x plus k, and you can get as x tending to 0, this will tends to 0, and the value would be k. So right hand limit is 1 and left hand limit is k, and the requirement of the question is this limit exists, hence right hand limit is equal to left hand limit, hence 1 is equal to k. So value of k is 1. So this was our introduction part of introduction to limit. We will have another part in continuation. You can go through them as well. So this was the basic concept of limit, and these are the basic building basic which apply in all the limits. Thanks.